Good afternoon, grade 10. I'm going to go over the assignment that I gave you the other day on relations versus function. And so I thought what I would do is use my IPvo camera to video me doing the work as opposed to trying to put it all on the chalkboard. So hopefully it goes a little bit faster. Maybe not for you, but it will for me anyway, because every time I have to stop and wash the board down. So maybe this will work a little bit better. We're all learning how to do this stuff differently. So anyway, this is how I'm going to try it today, and hopefully it works out. Okay, so the question is it a function or not? That's really what we're asking. And so if you remember correctly, one of the last things I said was that if it's a function, it will fit this definition. Every x has only one y. Every x has only one y. Okay, so that's what we're going to look at when we go through here. So we're looking at, if I have it set up as a table of values, then this is my x and this is my y. Okay, so in this particular case, the dogs are the domain, the x, and the y is my average height. So that's my range. Okay, this set of elements is known as my range, and this set over here is known as my domain. Okay, so I'm looking for every x only to have one y. So a hound, a dog that's called a hound, can only be 75 centimeters. A chihuahua can only be 20. And then remember, this is an average. A corgi can only be 30. A golden retriever, 60. A German shepherd, 60. A malamute, 65. Now, if I were able to have you in front of me in the classroom, I'm sure that there would be some people who would say, well, this must not work because, look, golden retriever has 60 and German shepherd has 60. This x, though, can only have one y. Golden retriever can only be 60. It's not like a golden retriever could be 60 and 65. So let me explain it to you this way. What you're looking for is, did the x's repeat? Did they have two different y's that they could be? It's not that every y can't have more than one x, it's that every x can only have one y. So this is actually a function. Yes, this is a function. Okay, now look over here. This one's different. Badminton, the sport. This is my set, the sport, and the equipment used is the other set. Now I'm making the association between the sport and the equipment used. Okay, so badminton, the equipment used can be a birdie, but also badminton, the equipment used can be a racket. So notice that this x has two different y's. A badminton can have a birdie, a badminton sport can have a racket. So it has two different y's. So what I'm looking for when I have them in a table of values is, does my x element repeat? And it does. So this one here is not a function. Every x does not have one y and only one y. So that's not a function. All right, now this is where we're kind of getting down into what it's actually going to look like when you start into the rest of this, these outcomes, because you know that most of the time in math we're talking about numbers and we're just going to have an x and a y, and a lot of times we have no real idea what the association is talking about. It's just relating numbers and numbers, and so that's kind of where we're going to land when we're finished with all this. I like that we start out with the associations being kind of grounded in something real, but as we move through, it's going to become a little more abstract. So the x here, look at how the x 1, 2, 3, 4, they only have one y. And yes, the y is repeating, but that's not what I said to look for. It says the x repeating. Okay, so this one is a function. Yes, it is a function. The number 1 is associated with the 8. The number 2 is associated with an 8. That's okay. Number 2 isn't associated with an 8 and then also a 9. Okay? 3 is associated with a 9. 4 is associated with a 9. Listen carefully. The 4 is not associated with both the 8 and the 9. The 4 is only associated with the 9. You might need to play that again and listen, because I know this part can get confusing because it's very much about the way I'm saying it. Okay, now let's look at this one. This is a perfect example. 10 is associated with a 30, but 10 is also associated with a 50. So this X has two different Y's it's associated with. This X has two different Y's it's associated with. That means that this one is not a function. And number 5. Let's look real quick. The 5, the 10, the 15, the 20, they don't repeat. So that's kind of what I look for when I'm talking about a table of values. And also when I start looking at ordered pairs, because ordered pairs are really a table of values just written in a different way, aren't they? So 5, 10, 15, 20, each X has only one Y. And so yes, this is a function. Okay. Number 6 and 7. These are arrow diagrams. Remember, arrow diagrams usually have a title, and I noticed that in the assignment that I gave you that I had forgotten some of the titles at the top of the arrow diagram. So if you notice that missing, go ahead and put that back on there for me, please. So these are the types of salmon over in, this is the set of different types of salmon. So remember, just a reminder of some different terminology. These are called, this is called the set. This is called the elements of the set. This is a different set, the title of the set, and then these are the different elements of that set. Okay, so the arrow diagram is saying these types of salmon have the mass in kilograms of this. Okay, so what we're looking for here is, again, this is my X side, this is my Y. So that on the X side, we call this also the domain. This is the range. And later on, we're going to be practicing actually writing down the domain and range. So I'm just trying to throw that in there so that every time it's starting to stick a little bit better for you, so that later on, when we start writing down what is the domain, what is the range of these different types of relations, then you'll be able to hopefully pull back from what we're talking about today and understand that. So when I look at a sockeye, it can have the mass of 6 kilograms. Okay, a pink salmon can have the mass of 3 kilograms. The coho can have a mass of 5, the chum 9, and the chinook 13. Each of these X elements has only one mass that it's associated with. Listen carefully. The sockeye can't both be 6 kilograms and 13 kilograms. It's saying it can only have one. And of course, again, this is an average. But so this would actually be a function. Yes, it's a function. Now look at the next one. The letters in Z words. This is the number of letters in these Z words. Okay, so, and I like that they put the number over here on this side. I should put number of letters. And the words on the other side, because it kind of would make it seem like the way that we've got this worded, or these different examples, like in this one, the arrow diagrams, that always the word goes on the left, and then, or in the X place in the domain, and then the range is always going to be the numbers, and that isn't necessarily true. So when I look at this one, the number of letters that we have in Zen, that works, but look here, 4. 4 is the X value, and it's associated with both 0 and it's associated with zany. So this number 4 is an X, and it has 2 different Y's. This X has 2 different Y's. Does that make it a function? No, not a function. Okay. All right. Number 8. Okay, let's see if I can get this lined up here for you. If you could only tell, this is actually, when I'm looking at it on my computer screen, it's upside down. It's driving me absolutely bonkers, but I'm trying to figure it out, guys. We're all learning something different. All right, so this was the square number, and this was the root number. So this was the square number is the square of this root. Okay, so the number 1 is associated with both the -1 and the 1. So that means that this x, remember the x is always on the left and the y is always on the right every single time. So this 1 is associated with both this -1 and with this 1. Right away, once I see that this x has two different y's. This x has two different y's. This is not a function. All right, now let's look at the months. Has this many days. So January has 31 days, but March has 31 days. What do you suppose? Does that make this a function or not? Now that's a tricky one because you're seeing this one and this one both going to 31. But does January go to two different places? No, January only goes to 31. Yes, March goes to 31 as well, but does March go to two different places? No, it only goes to one place. February only goes to one place. April only goes to one place. That means that every X has only one association with a Y. Each X has only one Y. This is a function. Next one, ordered pairs. Now, ordered pairs remind you an awful lot of taking your table of values, and basically this was your X, this is the X, and this is the Y. So, and that's always going to be the case. So when we have this X and this Y, what I'm looking for is, in the same way that I did with the table of values, does the X repeat? And in this case, look, it doesn't. So that means that this particular association was talking about the tickets to the cost. And so one ticket costs $1.75, two tickets cost $3.50, three tickets cost $5.25, four tickets cost $7. And of course, later on, we're going to talk about how this particular association is a function, and it's a specific kind of function we're going to talk about called a linear function. There are all kinds of different functions. This one is a linear function. We'll get to that later. But just notice that every X is only associated with one Y. And what I would be looking for is, does the X repeat? Because if it did, that would mean that it had two different associations. For example, if sometimes one ticket costs you $1.75 and then sometimes one ticket costs you $4, maybe that would be that they were talking about the tickets and the cost, and they had, the days of the week all thrown in there. So on Mondays it was only $1.75, but on Thursday nights it's only 75 cents. On Saturdays it doubles or something like that. So you could have one ticket being associated with two different costs, but in this particular one, this is all the information they gave us. And so in that particular case, each X has only one association in what they gave us. So we're calling this a function. Yes, it is a function. Now, what about this one right here? So I'm going to slide that up for you a little bit. So here we're talking about the association of the name of a town to the province or the state. And so, for example, Woodstock, you have a Woodstock, Ontario. You have a Woodstock, New Brunswick. You have a Marion, Indiana. This is where I went to university, by the way. Marion, Indiana. You have a Marion, North Carolina. You have a Marion, Ohio. You have a Heartland, New Brunswick. You have a Heartland, Wisconsin. Okay, so remember, in this scenario, whenever we have ordered pairs, the X is always on the left and the Y is always on the right every single time. So does the X repeat? Does the X Woodstock have more than one province or state that it's associated with? Yes, Woodstock is the X. It's associated with both Ontario and New Brunswick. Look, the X repeats. This X has more than one Y. Look, Marion happens again. Marion is associated with both Indiana, North Carolina, and Ohio. This X, Marion, is associated with three different Y's in that case. And then Heartland, this X, is associated with both New Brunswick and Wisconsin. Heartland, the X, is associated with more than one y. So this one right here is not a function. All right, now, last three here. Okay, so we have 0, 1, 2, 3. So again, I'm looking for, and this one's really abstract, right? Because we've got numbers, we don't have any words that we're kind of figuring it out. So I don't really know what these numbers are associating, what the association is. That doesn't matter. It's more abstract, but that's okay. I'm looking for the x. Does it repeat? No. 0, 1, 2, 3. So that means that each x has only one y. Now look at this one. So this one is a function. Is this one? 10, 10, 10, 10. That means that the 10, which is the x, is associated with the number 25. It's associated with the number 30. It's associated with the number 35 and the number 40. It has 4 different associations. This is not a function. And then lastly, 5, 10, 15, and 20. Each x only has one y. Notice I'm not even necessarily looking at the y's to determine whether they repeat. That's irrelevant. It's does the x have more than one y? So this one is a function. All right, then we had the second part of the lesson. And so it said with this one that it wanted you to create an arrow diagram based on the word association. And so an arrow diagram, we had Michael Jordan is associated with basketball, Tiger Woods is associated with golf, Sidney Crosby is associated with hockey. Thank you for the 2 boys who told me some different names. PK Subban, and who was the other one, Keith? I can't remember what you said. What was it? I'd have to go back and look. I've already forgotten. Isn't that terrible? And then Tom Brady is associated with football, and Derek Jeter is associated with baseball. Okay, so the way that they've got this worded, this part is always going to be my x. This is the part that's going to be setting up for my domain, and this is going to be my range. So I'm going to set this up like so. Okay, and so here are my my athletes, and here are my sports. And you think about it, it's interesting, isn't it? Because in my video that I did last time, I put the sports on the left and my athletes on the right. It didn't really matter in this particular case because usually the one that's in the domain spot is the one that's in charge. He's going to be the independent variable, and the one that's in the y is going to be my dependent. But this particular association isn't going to really matter which way I have it. So I'm going to just abbreviate again. So this is Michael Jordan, and then I had Tiger Woods, and then I had Sidney Crosby, and then I had Tom Brady, and then I had Derek Jeter. Okay, and then I had basketball, and I'm going to mix these up just so that it's, just a little bit different. My arrows don't go all the same. And then baseball, and then golf, and then I had football. Okay, and so I said Michael Jordan was associated with basketball, and Tiger Woods was associated with golf, and then Sidney Crosby is associated with hockey, and then Tom Brady is associated with football, and then Derek Jeter is associated with baseball. Okay, so based on the information that they gave me, this is how I have it written. And so this is actually a function, isn't it? Because every x only has one y. Now, if I wanted to be a devil's advocate, and if you're a real sports nut, you would know, and I'm not necessarily a real sports nut in terms of like knowing all my facts clearly, or I'd know some baseball or some hockey people, but Michael Jordan does happen to be one of my favorites, and I do know that Michael Jordan, for a little stint, actually stopped and played professional baseball. So if I really wanted to get down to the nitty-gritty, I could have put that he was associated with baseball as well. And then, would it be a function? No, it wouldn't, because actually Michael Jordan would be associated with 2 professional sports. But based on the information they gave me, and this is a little lesson for you, based on the information that they give you, then you create your arrow diagram. Even if you happen to know that there's more information to be had, you're using what they gave you. And that's a really important lesson for graphing. use what they gave you. Okay, so now it says create a table of values to show this association. Okay, so again, so if I have a table of values, then I have to set it up like so. I always put the elements of my domain, my set of my domain on the left, and I'm going to put my elements of my range on the right. So this is going to be my athletes, and this is going to be my sports. Okay, so Michael Jordan. Now this one does matter. I have to set it up with, I'm not going to have an arrow, so I have to make sure that it's lined right up with it. So Michael Jordan, then basketball, then Tiger Woods, and then he's golf, and then it was Sidney Crosby, he was hockey, and then it was Tom Brady, and he was football, and then it was Derek Jeter, and he was baseball. Okay. Now, lastly, it said to use the bar graph to create a table of values, an arrow diagram, and a word association. And then I threw in there as well that it should be ordered pairs, even though I think on the original it didn't have ordered pairs. But okay, so I'm going to use this information to be able to create a table of values. So first of all, let's just go over the graph. So on a graph, we know that this is always going to be my x down here. So this is always the x, and this is always the y. Always, always. The x is down here. This is my independent, and this is my dependent variable. Okay, so here's my independent variable. Maybe you should add this to your notes, please. Independent variable goes on that horizontal plane, and then the dependent variable is up here on the vertical. And that is always the way it goes, guys. It doesn't change on you. Isn't that nice about math? It just always sticks. It always stays the same. Okay, so you have Michael Jordan, and these are approximates, right? He's about 6'6". I think he's 6'6". I don't know. There's actually a documentary that just got on Netflix about Michael Jordan. It's called The Last Dance or something. I'll have to watch it. Anyway, then you got Mugsy Bogues. Again, this is going way back. So he's like 5'3", I think he was. And then you've got Mr. Hogan. He's 6 feet, about the same height as me. And then Matt Roloff. I'm not sure who that is. I can't even remember. He's clearly about 4 feet and, I don't know, 7 inches, I'd say, by that. And then Yao Defen must be one of the tallest people on the planet, I'd say. And he's like just about 7.5 feet tall. Holy smokes, that's huge. My son is about 6'9", so he'd be right about here. He's taller than Michael Jordan, but he's shorter than this Yao Defen. Okay, so I'm going to use this information to create a table of values. So my table of values, I'm going to set this up with my x over here. So just to show you what it looks like, I'm going to put my x, and then I'm going to go y, and I'm going to give it its title. So this is my name of my person, and this was the height in feet. And so we had Michael Jordan, and we said he was about 6 feet 6 inches, or if I want to put it all in feet, it would be 6.5 feet. And then we had Mugsy Bogues. Mugsy Bogues. He was in the NBA, by the way, if you didn't know that name. He was super short, eh? So he was about 5 1/4, let's say, approximately. And then you've got Mr. Hogan, and he's 6 feet. And then you had Matt Roloff. I don't know who this guy is. I don't know where that name came from, but anyway, he is, I would say, about just under 5 feet. So let's say 4 3/4 of a foot. So about 4 feet 9 inches. And then you got the Yao Defen, and I would say he's about 7.5 feet. So about 7 feet 6 inches. Okay, so there's your table of values. And then you needed an arrow diagram, keeping in mind that the arrow diagram reminds you of your Venn diagram. So you've got to have two circles like so. And then you're going to put your person here is the height, and you can put feet. You should always write the association in between the two circles, okay? And put the title. So you've got your person, so let's go ahead and abbreviate. So you got Michael Jordan, you've got Mugsy Bogues, you've got Mr. Hogan, we'll say Bill Hogan, you got Matt Roloff, and then you got Yao Deffen. Okay, and then let's just mix these up. So let's go 6'5", let's do 5.25, 6 feet, 7.5, and 4.75. Okay, so who was where? Michael Jordan was 6.5. Mugsy Bogues was 5.25. Mr. Hogan was 6 feet exactly. That's not a very good arrow, is it, guys? 6 feet exactly. This Matt Roloff was 4'7.75, and then Yao Deffen 7.5. Okay, all right. And then in sentences, this one can be a bit of a pain because it takes longer, but it is going to be there on your targets, so you do want to see it a little bit, okay? So we say Michael Jordan is associated with the height 6'5" feet. Okay, Mugsy Bogues is associated with the height 5.25 feet. Mr. Hogan, Bill Hogan, is associated with the height 6 feet. And then Matt Roloff is associated with the height 4.75 feet, and then Yao Deffen is associated with the height 7.5 feet. Wow, that would be really important for you to write that out if that was like on an exam or something, which of course you lucked out this year. You won't have to write an exam in this course. You guys are the only class I have ever had that won't have to write an exam. Aren't you lucky? All right, ordered pairs, last one. So let's go Michael Jordan, comma, we always put the X first, and then 6.5. Close your brackets like that, and then go on to the next one, Mugsy Bogues, and then 5.25, close it, keep going, Bill Hogan, 6 feet, Matt Roloff, 4.75, and then Yao Deffen, 7.5, okay? And there you have it. All right. So that is the answer key to all of that work. If you have any questions, please don't hesitate to put them on the team chat. Okay, so that took quite a while to go over that, but you know, because we're not in the classroom, getting a chance for me to actually do some of this work with you on the board, and some of this stuff is going to be shorter. In fact, one of the next things I'm going to post today after I do a really short lesson here again for I'm going to call lesson 3 is the targets. And of course, again, the targets are not worth anything. It's just about whether or not you get an opportunity to extend your learning a little bit. And so there's not a mark associated with this. Even one of the things that we actually got clarified for us today is that in grade 9 and 10, these aren't credits. So this is actually just going to be an ENR on your report card, or I think they might even put the numerical 0, even though it doesn't mean you didn't get anything. It just means that you were enrolled in the course and you did as much as you could. But there's no credit associated with this one, not this year. Okay, so you're all set, but I am going to put the targets out there for you, RF2, and you're going to get a chance to try them and then see how you do. Okay, and then so I'm going to do a little mini lesson for the next part of it. It won't take anywhere near as long as what this one took, and then I'm going to get give you an opportunity to do those targets, and we'll see how you do. Okay? So thanks for watching this. Hopefully this was helpful.